Good morning, and welcome to today's session about intelligent automation at ITW 2021. My name is Hatam, the Chief Growth Officer at Bankai Group, and I'm very excited to be with you today. As all of you know, network interoperability and automation is a challenging topic for the industry, but a worthwhile effort as it brings operational efficiencies, eliminates manual errors, increases customer satisfaction, and ultimately has a positive impact on the bottom line. Since Bankai Group is both a network operator and a solutions provider, we offer a unique perspective on the topic of automation that I would like to share with you today. Before we start, I would like to take a few moments to introduce Bankai Group and give you an overview of our telecom technology solutions. Bankai Group is a global leader in the information communication technology and services domain. The company has been offering voice and messaging services for both retail and wholesale partners for the last 3 decades. We have built most of our solutions in-house with an eye towards standards and interoperability. We're headquartered in New York with our main R&D center based out of India. At Bankai, our vision is to build solutions and services to accelerate the global telecom technology growth. We strive to provide innovative solutions to our customers so they can become more agile, reduce operational costs, and increase their revenue streams. In terms of Bankai Telecom solutions, we offer an array of BSS, NSS, and revenue assurance and fraud management solutions that we'll briefly introduce today. We offer a Converged BSS for Interconnect and roaming, allowing for a single platform to manage all the agreements and complex contracts for both voice and SMS. We've incorporated several configurable workflows that can fully automate many of the business processes, including vendor and customer management, trading desk, deal management, and network and routing optimization. In addition to managing the cost and margin, we make sure services are fully monetized by offering a full set of rating, billing, invoicing, and dispute management functionalities. Our revenue assurance solution is network and service agnostic, covering not only interconnect and roaming traffic, but also postpaid and prepaid retail traffic. It is built to identify and correct revenue leakages via a set of configurable control points from network elements up to billing and financial management systems. It is built to run in parallel to in-house mediation, rating, and billing to validate their functionality independently. Our fraud management solution monitors all network events, including CDRs, and uses advanced analytics to detect and mitigate fraudulent traffic, including toll bypass fraud, subscriber fraud, international revenue share fraud, and Wangiri or short duration call fraud. We offer Class 4 VoIP switching with real-time credit management and prepaid controls capable of handling high traffic volumes with independent scaling of signaling and media screens. We also offer a Class 5 enterprise-grade voice-over IP switching capable of delivering voice-over broadband, IPPBX, unified communications, and DID retail services. And last but not least, we offer traffic monitoring and revenue verification solutions, as well as test call generation for regulators and operators globally seeking actionable insights across their networks. Now that I've introduced you to Bankai Group and our telecom offerings, allow me to walk you through 5 key components of intelligent automation. These 5 components are digital process automation, or DPA. DPA involves automating workflows within and across applications and services via application programming interfaces, or APIs, to make it easier to sync data, get notifications, and perform common tasks. Robotic process automation, or RPA, automates manual tasks by reducing human interactions such as mouse clicks, keyboard strokes, or data entry, then playing those actions back as intelligent workflows. RPA captures automation in forms of bots that perform the task automatically and efficiently. These bots leverage low-code or no-code interfaces that anyone can use to automate repetitive tasks. So it's important to design applications with low-code and no-code capabilities in mind. AI/ML plays a key role in analyzing the data and extracting insights ranging from network anomaly detection to predicting customer churn. It can also be added to RPA to effectively train the bots to be more intelligent in troubleshooting networks, as well as providing much better level of customer experience. Open APIs offered by many standard bodies open the door to interoperability as well as equipment agnostic architectures. With these 5 categories in mind, we'll now cover some real life examples. Our first example of digital process automation is a platform that combines VoIP switching, BSS OSS, and customer self-care portal. Customers can seamlessly sign up for termination services, as well as DID and UC services, finalize online agreements, and make online payments. Backend APIs for account, product, and service provisioning allow services to be up and running in near real time. The sign-up process starts with a user-friendly interface supported by an automated workflow in the backend. Post-sign-up, customers can complete their registration in case of prepaid, make online payments, establish network connectivity, and start testing their interconnects and finalize online agreements or contracts. Automation across the portal, BSS, and switching stack in effect produces flow-through provisioning, detailing the signaling protocol used, the number of ports to be allocated, and the expected traffic burst, or CPS. As you can see, digital process automation works to hide many of the complexities from the end user while enforcing data validations and business rules from the back end. Another example of DPA is network routing optimization. The key to routing optimization is to parameterize the inputs needed by the optimization algorithm, while allowing users to control what is most important to their network operations as well as commercial objectives. For example, some users might want their retail traffic stream to be optimized based on quality or CLI guarantee routes and then cost, while their wholesale traffic streams should be optimized based on margin or lossless LCR and then quality. And of course, certain traffic streams need to strike a balance between quality, margin, and the available capacity on the network. Another key element is to have a feedback loop from the network to allow algorithms to self-correct and be fully aware of how what is being suggested is getting implemented by the network. For example, when using percentage routing for traffic distribution across multiple vendors, it's important to measure the actual traffic distribution via the completed and incomplete CDRs, and then readjust distribution in the next set of instructions to the network. Another good example of DPA is dynamic routing engine, also known as centralized routing engine. This way, all routing policies are kept in a central server, and the soft switches or SBCs use the SIP redirect methodology to obtain routing instructions on a call-by-call basis. This approach is also used to route calls not only based on call destination, but also origination. This is very much applicable to the wholesale traffic today, especially in the EU zone. Integrated revenue assurance and fraud management platform with end-to-end automation also belongs to the DPA category. This solution includes an independent mediation platform to collect network data, as well as subscriber data from various network elements, and post-mediation feed the results into RAFM components. Many operators prefer this approach to fully audit their existing in-house solutions for accuracy and precision. There are 5 key building blocks in a complete RAFM solution. The mediation we've already covered. A rules-based engine and an AI-based engine are needed to work hand in hand to complement each other. Some tasks, such as pattern checks or threshold checks, are best done in a rules engine, while profile checks, velocity checks, collision checks are best done via AI engine. By incorporating signaling traffic, we can open the door to real-time fraud detection, as well as real-time mitigation of fraudulent traffic. Test call generation or test calling provides an additional test or additional tool to signaling and CDR profiling, and allows for the reduction of the number of false positives. Here we see a comprehensive RA workflow starting from data collection all the way to defining reconciliation, alerting, and case management. It's important to automate this workflow as much as possible, since the number of control points and the volume of records monitored can become staggering, especially as it relates to data usage and GPRS records. At this point, let us discuss robotic process automation, or RPA. Case management refers to the ability to capture alarms and network events in what is called a case or a ticket, which can then require further investigation and follow-up. Some end-to-end processes can be manually intensive, requiring human intervention at different stages of this life cycle. By applying RPA to case management, bots can be trained to open cases, perform troubleshooting, and take actions to resolve cases while notifying the respective departments automatically. Like anything else, the 80-20 rule applies here, as certain network events or conditions will always require human intervention. To better understand low-code, no-code, let's have a look at this configuration for SymBox detection. SymBox fraud detection involves a combination of rules. If the solution is not flexible enough, then software development is required. With this tool, the user has two options to create rules. One is to use a function, and the other one to use an expression builder. With functions, the systems provide different capabilities like counts, aggregations, distinct occurrences, as well as configurable thresholds and mathematical conditions to achieve the objective. The expression builder is the best choice for more complex rules. It allows building mathematical expressions by combining multiple parameters such as total outgoing calls, geolocation data, SMS count at NZ level. In a nutshell, low-code, no-code solutions pave the way for intelligent automation. And now that we've covered the low-code, no-code concept, let's look at the use of AI/ML in intelligent automation. The basic framework for using AI/ML includes the following steps: creating a business case with clear objectives and KPIs, data engineering to build data pipelines to extract, cleanse, and enrich the data with the applicable features for model building, choosing the right algorithms to build and train the models, deploying models into live environments and refining them based on accessing the ground truth, visualizing the results and allowing analysts to further discover the insights. Another important aspect of intelligent automation is to access the data in real time or in a streaming mode versus batch processing. This opens the door to much faster event processing, such as real-time event monitoring and data capture, real-time transaction profiling, and correlation. The above example uses an ELK stack. ELK stands for Elasticsearch, Logstash, and Kibana, which offers instantaneous insights of network events, logs, application status, and system statistics. It also uses Apache Flink, which is a real-time log processing application along with in-memory aggregation. It can fetch data from messaging queues like Kafka and push it into Elasticsearch. The ELK stack can perform super fast data extraction to generate the near real-time data insights. Kibana offers the visualization. The highly interactive user interface will ease the job of analysts in detecting and analyzing the data. There are many ways to visualize the results of ML models, ranging from heat maps to scatter plots. It's important to choose a flexible visualization layer, for example, using time series graphs to compare predicted behavior versus the actual. Finally, open standards foster interoperability and prevent overdependence on a single vendor or equipment provider. It also opens the door for innovation as well as collaboration between carriers and operators. There are many standard bodies that offer open standards. TM Forum, for example, focuses on services and resource ordering and provisioning. MEF offers lifecycle service orchestration at B2B and B2C layers. And ETSI 3GP focuses on network function services like 5G slicing. The above example depicts a federated orchestration architecture that can be used for managing a multi-operator 5G network slicing. It's important to note that both the north-south as well as east-west APIs play a key role in allowing for full automation within and across networks. In addition, a common clearing and settlement layer is paramount and can be enhanced with smart contracts and blockchain technology. On that note, we've reached the end of our presentation. I want to thank you for attending today's session and hope that you found it useful. Please feel free to contact us or stop by our suite at ITW. We would love to hear your feedback. Wishing you a wonderful rest of the week at ITW and stay safe.